Hello everyone. In this session, let me continue the theorems and complex analysis, and it is one of the important theorem. We say this as Cauchy's theorem on triangle. So it is 14 mark question. By seeing the marks, you can guess that how many pages the theorems would be. Anyhow, let me explain. You have to remember along with the statement. So proving Cauchy's theorem on triangle. Or Cauchy's theorem for a triangle, it is important question. Statement: let delta be any triangular contour in a simple connected domain D, then we have to prove that over that domain f of z dz value is 0. Fine. So just I am going to explain, I'm going to simplify the steps only, but remaining theory part I will be telling manually. But anyhow, I will send you the notes, but I will not going to write all the wordings and all here. Just I will do the calculation. Now, given that delta is any triangular contour, so let me consider one triangle. Fine. In a complex contour, that is in a region D, domain D. Fine. Now, what I'm going to do is, whatever I'm telling now, I'm going to write the same in the wording form. First, let us consider a triangle in a complex domain D. Now, first let me join midpoints of sides of a triangle. So this is the midpoints of a sides of a triangle, right? So this side, this is a midpoint. For this side, this is the midpoint, and this is the midpoint. Now what I'm going to do is, I'm going to join the midpoints of sides of a triangle by a straight line, right? So something like this. Let me complete the triangle. This comes in this direction, again in this direction. Here direction of arrow marks is also important thing. So I have joined the midpoints of triangle so that I can obtain 4 congruent triangles. Let me take this as triangle 1, triangle 2, triangle 3 and triangle 4. By joining midpoints of triangle, sides of a triangle, I have obtained 4 congruent triangles, right? The meaning is that I can split the given triangular region f of z into dz into 4 spaces. That is, along triangle 1 f of z into dz plus along triangle 2 f of z into dz plus triangle 3 f of z into dz plus along triangle 4, that is overall region f of z can be splitted along 4 triangles, that is f of z into dz. So whatever I have explained, you have to write all the explanation in terms of wording, so that it will become at least of off page. So it will be like that only. So I have divided it into 4 regions. So let me take this as equation 1. I'm just writing the simplification part, that's all. Now, from equation 1, it follows that I am explaining the fact that each of the 4 integral can be replaced by, you just listen to me carefully. Equation 1 says that each of the 4 integrals, whatever 4 integrals we can have, can be replaced by sum of the 3 integrals taken along the separate sides of a triangle, so that the 6 of the resulting integrals will be equal to 0. Meaning is that, see here, suppose if you are going to right now I have 4 triangles. So here you can observe the direction of arrow. This side, and this side. Totally how many triangles? How many sides we can follow? See here, 1, 2, 3. In each triangle, 3 parts. 3, 3, 3, 3. 3 1s are 3 2s are 6, 3 3s are 9, 3 4s are 12. 12 sides we have. Among that, 6 sides is repeating twice, right? See here, 1, 2, 3, 4, 5, 6. You can look at the direction of pen. 1, 2, 3, 4, 5, 6. So these 6 sides will be repeating 2 times. So by removing repetition, we can obtain remaining sides by 6 resulting integrals, right? Remaining integrals, see, these 6 integrals will be 0 as it is repeating twice, that is in opposite direction. Fine. Now f of z can be, if you are going to take modulus of this f of z, we can write modulus as modulus of sum is less than or equal to sum of the modulus. I'm repeating once again, modulus of over sum will be less than or equal to sum of its modulus. I'll just write it here. See here, I'm going to apply modulus for this, so that you will get modulus of integral f of z will be equal to, I'm just applying modulus for this, so I can write f of z dz plus whatever the step I have, just I'm taking modulus over it, f of z dz plus over triangle 3 f of z dz plus along triangle 4 f of z dz. I have taken modulus over the above step. Now I have already clearly told you, whenever we are going to split the modulus, it will be less than or equal to. So I am just splitting the modulus, so that I can write integral delta 1 f of z into dz plus integral along triangle 2 f of z into dz plus integral along triangle 3 f of z into dz plus modulus of integral along triangle 4 f of z into dz. Clear? I have taken a modulus on both sides and I have split it into 4 terms. Now let me take this as equation 2. Clear? Integral f of z dz. Now let us take this value, that is overall integral value will be equal to capital M. Let me take this as equation 3. Let us take this value as equal to M. Suppose if this value, LHS value is equal to M, then from equation 2, what is the conclusion that we can say? In the sense, if this value is equal to M, M will be less than or equal to all this sum. In the sense, each and individual modulus value, that is integral value, should be at least less than M by 4. In the sense, it should not be less than M by 4, right? It should be greater than or equal to M by 4. See here, it should be M by 4, at least M by 4 it should be. And meaning is, this value, minimum value of the each and every integral will be M by 4. See here, when it will be equal to M by 4, minimum M by 4, then when you're going to add this value, you will get M only. So that equal condition will satisfy. So for this value to be less than all this sum value, each and every integral value will be at least M by 4. In the sense, it should be greater than or equal to M by 4. Thereby, I can write that f of z dz modulus will be greater than or equal to M by 4. It cannot be less than M by 4. At least it should be equal to M by 4, or it will be greater than or equal to M by 4. It should not be less than M by 4. Why? Because if it is equal to M by 4, all this sum will be equal to M. M by 4 plus M by 4 plus M by 4 plus M by 4 will be equal to M. Why? Because this LHS value is equal to M. So if it has to be less than this value, each and every integral value should be greater than or equal to M by 4. Fine. Now we divide delta 1 wherever we have a triangle delta 1. Again we are going to divide delta 1 into 4 congruent triangle as we done for the first triangle. See here, I'll just show you one example. Let me consider delta 1 here. Again, no need to write this. I am showing for your reference. Again, I am going to divide delta 1 by joining its midpoint. So you are going to get again 4 triangle in a first triangle. Again, if you do the same, see here, for the second triangle it will be something like, see here, second triangle, that is delta 2 is here. Again, if you join these two midpoints, you will get like this, right? Again for delta 4, where you have it, here it is, right? So again, if you join midpoints, again you will get few more triangles, right? So if you repeat for each and every case, that is for each and every triangles, if you keep on joining the midpoints, let me write for the second one. So f of z delta 2 into dz, it will be greater than or equal to 1 by 4 times M by 4, right? Why? Because for each triangle you will get again 4 sum of the integral. For each of the region we can express it as 4 terms, sum of 4 terms. So that is why I have written 1 by 4 into M by 4. So if you continue this process, we obtain a sequence of triangle. For each and every triangle, if you keep on joining the midpoints of a triangle, you will get a sequence of triangle in such a way that they will satisfy the following condition. 4 conditions they will satisfy. First condition is that the length of, that is delta of n plus 1, should be properly contained in delta n. And second one is that length of each triangle will be equal to L by 2 power of n. Let me take this as Ln. Fine. And each second condition. Third condition is that each triangle is contained in another triangle. it is clearly visible, right? So each triangle will be contained in one more triangle. And the fourth condition is that integral over delta n f of z into dz, whatever the value of n, that is whatever the triangle you are going to choose, all the values will be greater than or equal to m by 4 power of n. This is something like a generalized case. See here, for the first case what I have obtained, for the first triangle it is greater than or equal to m by 4. For the second triangle it is 1 divided by 4 square into m, or m divided by 4 square I can write. So for the generalized case it is m divided by 4 power of n. Fine. So meaning is that if you are going to choose any point inside the triangle, every point will be differentiable. So let me consider the concept of differentiability. As per the concept of differentiability, what I can say as limit z tending to z naught f of z minus f of z naught divided by z minus z naught is equal to f dash of z. That is differentiability of function z can be written as this, as per the definition. Then what it says, for every epsilon greater than 0 and delta greater than 0, difference of this will be less than epsilon, right? When do we say function is differentiable? When difference will be, magnitude of difference of these two values will be less than epsilon, right? So I am just writing the same f of z. I already explained all these concepts in a basic. So minus f dash of z will be less than epsilon whenever z minus z naught is less than delta, right? I have considered the concept of differentiability. Now let me take, instead of epsilon, suppose if it is not a small quantity, so I can write z minus z naught minus f dash of z. Let me consider this value as some h, that is function of z, some function of z, and in such a way that magnitude of this function will be less than epsilon. What I have done is I have considered the concept of differentiability. Fine. So instead of epsilon, what I have done is let it be a function of z. Moreover, this function is very small, that is which is less than epsilon. Fine. Now in such a way that f of z can be expressed as f of z naught f dash of z naught into z minus z naught plus h of z into z minus z naught. Let me take this as equation 5, and let me take this as equation 4, or else let me, z minus z naught less than 4. Let me take this as equation 5. Now meaning of this statement is that since z naught belongs to nested triangles, that is triangle inside the triangle, so z naught will be arbitrary point inside the triangle. So as ln tending to 0, that is length of triangle tending to 0, meaning is n tending to infinity, right? So as n tending to infinity, this length will be tending to 0. So for every positive integer, for all n greater than n, we can say that mod of z minus z naught will be less than delta, that is difference of any 2 point will be very small comparatively. Now before going to next step, I'll tell you one hint. You just remember, if you are going to take integral over integral of any function over any closed curve, that is closed contour, the value will be 0. Fine. And this concept will be further, you will get it in fluid mechanics. It will be in third sem. Remember, integral over any closed curve will be equal to 0. Why? Because for a closed curve, upper limit and lower limit value is same. I'll give you simple example. See here, if f of z is z, so for a closed curve, upper limit and lower limit is same. So when you're going to get a function, when you're going to differentiate this, you will get z square by 2. Upper limit is 1, lower limit is 1. When you substitute limits, you will get 0. So that is the meaning of integral over closed curve. So integral over closed curve is always equal to 0. So you remember that concept. Now what I'm going to do is I'm going to integrate equation 5. So let me integrate over delta n over closed curve, which is equal to integration over closed curve f of z naught into dz plus integral over closed curve f dash of z into dz plus z minus z naught, into, right? So I'm just integrating this, plus h of z into z minus z naught into dz, integral over closed curve. Now you can note that just now I have told you integral over closed curve will be equal to 0. See here, f of z naught over closed curve. So this value will be 0, this value will be 0. But third value will not be 0. Why? Because we don't have any function of z. We don't have any closed curve. We have extra term here. here also we have an extra term, but here what we have, differentiation of a function, so that value will be 0, but h is not a function here. So h of z is very small quantity, it is like a epsilon value, so it is very small, and anyhow h of z, when you're going to take modulus, it will be epsilon. So epsilon into z minus z naught will be a constant term. Fine. So it will not be equal to 0. Why? Because it is not a closed curve, integral over closed curve. So you have to keep this term as it is. Now to evaluate integral over delta n h of z into z minus z naught into dz, we first note the distance between any two points of a triangle cannot exceed perimeter of length. In the sense, if you are going to take any 2 points in a triangle, if you are going to take distance between any 2 points, it cannot exceed this perimeter, right? It should be inside a triangle. Meaning of that, suppose if z is here and z naught is here, meaning is z minus z naught should be less than length of a triangle ln. Why? Because in the condition I have taken length as ln. So z minus z naught should be less than ln. Now I am going to evaluate this integral. So let me evaluate here. So when you are going to consider magnitude of this integral, delta n h of z into z minus z naught into dz can be written as, I am going to split this, so I have to apply less than or equal to, I am going to split the magnitude. So I can write magnitude of h of z into magnitude of z minus z naught into magnitude of dz. Now you can note that h of z is epsilon, that is magnitude of h of z is less than epsilon. I have written here, see here, h of z is less than epsilon, so I can write this is epsilon. Now z minus z naught will be obviously ln. So what you left with is integral over delta n magnitude of dz. So magnitude of dz is none other than length of a triangle. So length, magnitude represents length. So length is what I have taken, it is ln. Again it is epsilon ln. Clear? So I can write this as epsilon ln square. Again ln I have taken as, see here I have written here, ln is none other than L divided by 2 power of n. So I'll just substitute L divided by 2 power of n whole square. So it will be less than or equal to epsilon into L square divided by 2 square is 4 power of n. I can write this as epsilon into L square divided by 4 power of n. Now let me write LHS as it is. What it is? Magnitude of delta n h of z into z minus z naught into dz value is this one. Now let me consider this value. So what is the LHS here I have? So I'll just write here integral over f of z dz will be equal to, what is the left whole term here? It is delta n into h of z into z minus z naught dz. Fine. So here I have evaluated the value. So the value of this function I can replace this with epsilon ln square by 4n. So thereby I can write delta n, this value f of z dz will be less than or equal to epsilon into L square by 4n. Clear? Now let me consider equation. I have not given any name, so let me consider this as equation A. Fine. So from equation A, I'll just write here magnitude of delta n f of z dz is greater than or equal to m divided by 4 power of n. Right? This is what I have. Now somewhere I have chosen m value. See here, m is, that is m, if you simplify this, so by this equation, see here, m is integral over delta f of z into dz. From equation 3 I can replace this as, see here, I can just write this f of z dz magnitude will be greater than or equal to 1 by 4 power of n. I'll keep as it is. Now I'll replace m with this value, that is magnitude of integral over delta f of z dz. You can note that this is for generalized case delta n, this is for single, that is delta f of z into dz. Fine. Now I'll just do cross multiplication. So you will get 4 power of n into magnitude of delta n f of z dz will be greater than or equal to integral over delta f of z dz. Right. Now what I have proved is for delta n it is epsilon L square by 4n. for delta n. So I'll just reverse this equation. So I can write this as delta f of z into dz. I'll just remove the magnitude, so it's not a problem. I can write this as less than 4 power of n into integral over delta n f of z into dz. I just repeat once again this statement. Suppose if a is greater than or equal to b, I can write this as b is less than or equal to a. So that I have applied the same concept. I have reversed it. Clear? Now I'll just write this term as it is. Now you can note that integral over delta n f of z into dz value is less than or equal to epsilon L square by 4n. So I'll just substitute here epsilon L square by 4 power of n. Now 4 power of n get cancelled. You will get less than epsilon L square. So integral over delta f of z into dz is less than or equal to epsilon L square. Now epsilon is arbitrary quantity. So as we increase the values, as we keep on dividing the triangle, this epsilon value will be very small and it can be negligible. At last it will be equal to, as we increase the values of triangle, that is length of a triangle, epsilon will tend to 0. So therefore I can write integral over f of z dz will be equal to 0. And that is what we required to prove is. So if you add whatever the explanation I have told you in this session, you will get approximately 3 to 4 pages, but you have to practice. This theorem is very important. It is for 14 mark question. 14 mark question. In this first unit totally you have 3 derivation which is for 14 mark. So among 4 derivation you will get one derivation definitely. Fine. So this is what I have. Whatever the explanation I have told you, I'll send you the same in a notes format. You just write it down. So simplification is quite easy. So you just go through the video. So hope so it is clear. So that is what we need to prove is, see here, integral f of z dz over triangle is equal to 0 over triangle delta is equal to 0. So this is what the proof is. Hope so it is clear. So in the next session also I am going to prove the second theorem, that will also for 14 mark. Since in this session I have done it for triangle, you are going to do the same for rectangle in the next session. Thank you. And the notes will be forwarded in the group. Please copy the same.